Something so small could be so big. We can have it all. It starts with Nanotube TV. It starts with Nanotube TV.
Hello and welcome to Nanotube TV. I'm Dr. James B. Lewis. For 25 years I did molecular biology research because as a child of the 1950s, inspired by science fiction and comic books, I dreamed of curing aging and traveling to the stars. Basically, I wanted to discover the laws that govern the universe and to learn how to apply those laws to better the human condition. Well, in 25 years, I never did get around to studying aging. But about 26 years ago, I began reading about and becoming fascinated by the emerging field of nanotechnology. And for the past 16 years, I've spent most of my time studying and writing about nanotechnology. So what is nanotechnology and why is it so important? Well, the name nanotechnology derives from the prefix nano, which is used in science and technology to mean a fraction of 1/1,000,000th. Specifically, a nanometer is a distance of 1/1,000,000th of a meter. And nanotechnology is about controlling the structure of matter on a scale of a nanometer or a few nanometers. To explain just how small a nanometer is, it's common to compare 1 nanometer with the diameter of a single human hair. Now naturally human hairs will vary in just how thick they are, but on average a human hair is about 80,000 times thicker than 1 nanometer. More to our point in terms of the technology of nanotechnology, 1 nanometer is the distance of a small number of atoms lined up side by side. Now, when you get down to the atomic scale, distances aren't quite as firmly delineated as they are at the human scale. So just how big an atom is depends upon just what property you're measuring. Are you measuring the radius at which one atom begins to repel another atom? Or are you measuring the length of a chemical bond between two defined atoms? Also, atoms are different sizes. The smallest atoms are hydrogen atoms, and you could line about 20 hydrogen atoms up side by side and they would span a distance of 1 nanometer. For much larger atoms, say cesium atoms, you could barely squeeze 2 atoms into 1 nanometer. For the atoms that make up most of the human body, typically carbon, nitrogen, and oxygen, it's about 6 or 7 atoms to 1 nanometer. So we can see that nanotechnology is fundamentally about atoms, and in this sense it's very closely related. It overlaps a lot with chemistry. But nanotechnology is very interdisciplinary. It also involves things like surface physics, material science, biotechnology, computation, and various forms of engineering. When we can control the structure of matter just even to a few nanometers, we're already making materials and devices that have a wide range of novel properties that are very useful. And in coming episodes, we'll be talking a great deal more about this. So nanotechnology is producing really cool and useful consumer products right now. And over the coming decade, as progress in nanotechnology continues, it will revolutionize a wide range of technologies, materials, computers, energy, environmental remediation, and perhaps most of all, medicine. But the really exciting potential of nanotechnology lies several decades in the future. As we get better and better at controlling the structure of matter, we will eventually arrive at atomic precision in manufacturing. We will be able to manufacture complex devices, machines, and even systems of machines in which every atom is in a designed position. Every atom is where it's supposed to be to have a particular function with respect to all of the other atoms in this particular machine. Now, to understand why this is such an exciting development, we have to take note of the fact that building complex systems of molecular machines, manufacturing to atomic precision, is exactly what life is all about. And that tells us why this is so exciting and why there's so much potential in this field. When we are able to achieve the level of sophistication that biological systems have achieved today and have achieved for the nearly 4 billion years that life has evolved, we will be able to build marvelous systems of complex molecular machines. And because our systems will be designed rather than slowly evolved, we won't be limited to working with the soft materials with which life has worked. We'll be able to use a wide range of materials, strong materials held together by strong covalent bonds. And many of these systems will end up looking somewhat like living systems, but many of them will look very different. They will be built from different types of materials. They will have a different range of capabilities. They will be able to do a wide range of things. When nanotechnology reaches the point of being able to inexpensively manufacture complex systems to atomic precision, which life can do now, we will be able to do marvelous things. We will be able to inexpensively cure essentially all diseases. We will be able to inexpensively and massively reverse the ravages of aging. We will achieve essentially complete control of the structure and functions of our bodies. We will be able to manufacture a wide range of consumer products cleanly and, of course, inexpensively. We'll even be able to manufacture our food to provide the very foods that we're used to consuming, but without the need to sacrifice animals to do so. We'll be able to build computers that are less expensive, far more intelligent, far more powerful than anything that we have available today. With these computers, we will have robots that will be available to assist us with all the jobs that we need to do. We will have inexpensive building materials with strength-to-weight ratios 100 times those of anything that we have available today. With all of these capabilities, the entire solar system will be open to, first, human exploration, and then human settlement. What are the implications of atomically precise manufacturing? What will the implications be for our lives once this technology is developed? What are the frontiers today in nanoscience and nanotechnology? What products are being developed and will become available over the coming decade? What are the different pathways, the routes by which we will progress from current-day nanotechnology to advanced nanotechnology? What are the choices and options that we will have available to us, the decisions we will have to make as we go along this journey. What a marvelous journey we have waiting for us. And we look forward to exploring it all with you here on Nanotube TV.
Nanotube TV.
It starts with Nanotube TV. Something so small could be so big. We can have it all. It starts with Nanotube TV. Something so small could be so big. We can have it all. It starts with Nanotube TV. It starts with Nanotube TV.
Nanotube TV.
Hello, welcome to episode 2 of Nanotube TV. As we continue our journey to understand the laws that govern the universe and how nanotechnology will afford us the opportunity to improve human existence to the ultimate limits laid down by physical law. Now, we saw in episode 1 that nanotechnology is an emerging technology that's about controlling the structure of matter at the nanometer scale, and that as nanotechnology develops to its ultimate limits, it will be about atomically precise manufacturing, being able to inexpensively and in a very general way make arrangements of atoms for whatever purposes that we have. So fundamentally, nanotechnology rests upon the concept that our world is made up at its most basic level of eternal and indivisible particles called atoms. This concept was developed in antiquity, most clearly during the 5th century before the Common Era, by the Ionian Greek philosopher Democritus. Now, we know today that the ancients got most of the details wrong. In fact, atoms are neither eternal nor indivisible. We know now that atoms have a very complex substructure. But for the most part, this substructure is only important at energy scales far greater than those we encounter in our everyday life. So in a very real and fundamental sense, in terms of our bodies and in terms of the everyday world in which we live, atoms are indeed the fundamental building blocks. Over the past few centuries, our knowledge of atoms has evolved. So by the early part of the 20th century, we knew that our everyday world was largely explained by the arrangement of the atoms of the chemical elements. Indeed, this notion of the importance of atoms is so fundamental that in his lectures on physics, the Nobel laureate physicist Richard Feynman has said, if in some cataclysm all scientific knowledge were to be destroyed and only one sentence passed on to the next generation of creatures, what statement would contain the most information in the fewest words? I believe it is the atomic hypothesis, or atomic fact, or whatever you wish to call it, that all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. As early as 1929, one scientist began to think about the implications of our emerging ability to control the arrangement of atoms. J.D. Bernal was an early pioneer in X-ray crystallography who helped determine the arrangement of atoms in small crystals. Bernal wrote an essay called The World, the Flesh, and the Devil, which has been called by Arthur C. Clarke the most brilliant attempt at scientific prediction ever made. Bernal predicted that we would combine physics, chemistry, and mechanics to produce arrangements of atoms that were not merely mimics of what we already found given to us in nature. Already we know all the variety of atoms. We are beginning to know the forces that bind them together. Soon we shall be doing this in a way to suit our own purposes. Bernal saw us using these capabilities to produce energy directly from sunlight, to synthesize our food directly from chemicals, to alter our bodies to cure diseases and extend lifespans, to support large populations living on the earth in health, wealth, and happiness. Bernal further saw humans using these capabilities to build habitats in space. These habitats have since been named Bernal spheres. A Bernal sphere would be about 10 miles in diameter and would support 20,000 to 30,000 people living in comfort, using energy from the sun to recycle all the materials they need to provide for food and all their other needs. Now, because only 1/2 billionth of the energy produced by the sun is captured by the earth, Bernal saw that populations using these spheres to live in could support vastly larger populations than could be supported on Earth. Bernal's visions were not even limited to the solar system. Over thousands of years, he saw humans adapting these spheres to make starships so that they could journey to the nearer stars and eventually even perhaps throughout the entire galaxies. Bernal considered that eventually human intelligence would be able to re-engineer the stars themselves. He noted that stars, especially the larger stars, burned huge amounts of fuel very quickly, and then after relatively short lifespans, ended their lives with huge explosions. He predicted that advanced intelligence would be able to re-engineer the stars to make them into efficient heat engines, and by so doing would extend the life of the universe millions upon millions of times beyond what it would otherwise be. Besides, he noted, we are far too close to the birth of the universe to be certain about its death. Bernal thought very hard about what would be the implications of our emerging ability to rearrange atoms. He thought about the implications for human lives, human societies, and even for the universe itself. But the first scientist to really explore the advantages that we would have if we would be able to arrange atoms the way we want them, and to suggest one way that we might be able to do so, was the Nobel laureate physicist Richard Feynman. In 1959, Richard Feynman gave a talk which in retrospect laid out the contours of the field that would become known as nanotechnology. When you return to visit us for episode 3 of Nanotube TV, we will explore Richard Feynman's vision of what has become known as nanotechnology.
Nanotube TV.
It starts with Nanotube TV. Something so small, be so big. We can have it all. It starts with Nanotube TV.